Assalamualaikum my students, Alsar here, welcoming you again to our unit differentiation. We have already discussed several topics that are present in this differentiation, and we know now how to say a function is differentiable at some point in its domain. And when the function is differentiable at some point in its domain, then this limit x tends to a f of x minus f of a divided by x minus a, it exists finitely, and we say this limit as differential coefficient. Differential coefficient, or we also say it the derivative of this function at point x is equal to a, or the third name for this is the slope of a tangent at point a of this function f of x. Now the procedure that we are following to find out this slope of tangent or this f dash of a, that procedure, that technique is called the differentiation. So you can write the differential like this. The process of finding the derivative, the process of finding the differential coefficient of a function f of x at point x is equal to a in its domain is called differentiation. It is called differentiation. First of all, in order to find out this differential coefficient, the function must be differentiable. And to check whether the function is differentiability, we have to find out the limit of the function at that point, f of x minus f of a divided by x minus a. We have to find its limit. Now, today we are going to define this differential coefficient in some other way. First of all, we will find out what actually the increment of a variable means in mathematics. If we have a function y is equal to f of x, for example, this is my f of x and this is my point x. The point x is here. If we give small change to this x, either from left or towards the right, for example, if I will give x the small change as plus h, so it will come out here x plus h, so it will be now here, and this distance, this change that we have made to this x, it is called increment. So that means the increment of the variable x is actually the smallest change in variable x. But when we will change, when we will give the increment to this x, or when we will give the small change to this x, it will, this is my f of x, it will give the corresponding change to this f of x, to this function. Why? When we have value of x here, we know here is the coordinates of this point here, x and f of x. But now, when we will give the value of this x as increment h, so it will come here, the point will be now here. So clearly, if this is x plus h, here the function will, the value of the function will also get changed. It will also get incremented because of the fact that this is greater. When you look here, it's similar greater than this, and definitely it will give the, so giving this increment to x, it gives the corresponding change to the variable y. So we can say that the increment of y is dependent on the increment of x also. So smallest change in x is called increment, and the corresponding smallest change in y is called increment of y. So you write down the smallest change in x is called increment. Is called increment of x, and it is denoted by del of this, del of or this del. So this represents the del x or del, it represents the increment of variable x. Similarly, the corresponding increment of dependent, this is dependent value because its value depends on the values of this x. Similarly, the corresponding increment of dependent variable with respect to the increment of this independent variable is called increment of y, and it is denoted by del y, or we write it as delta y. So this is the increment of y and this is the increment of x. Now let's check here, beta. If this is our y-axis and this is our x-axis, so करूँ f of x, so करूँ f of x. For example, this is my point x. If I will give the increment to this x, so it will be here now, and when I will join this with the curve, so here it will be now x. I will take the increment as del x, so it will be x del x, but it will give the corresponding thing to this f of x. So here it will be now f of x plus del x. So this point is now x plus del x and f of x plus del x. So now if I draw the perpendicular from this point to this line, so here we are now here x plus del x. So the increment of this x is del x. So this distance is after this, this is p, this m, this is t. So here I will make it. So we just, because it is getting here small and you are not getting it. For example, this मैं करूँ, इसमें point sorry, इसमें point x. This is my x plus del x. This is my p and this is my q. So here the coordinates of the p I am taking as x, f of x. Similarly, this increment of x is del x, and the increment here, if I draw the perpendicular increment of m, it will be del x. Now if I join this chord PQ like this, so now you check here, this ordinate is p of px positive, but when we are giving the increment to this x, we are getting the increment of this px as q, this t for example. Now the increment of this y is from this m to q, and that we denote del y, and this is del x, this is del y. Now suppose we have y is equal to f of x, and when we are giving the increment of this y as y, this x as f of x plus del x, we are getting this y equals to y plus del y, and this becomes equal to f of x plus del x. Now when I subtract from this first equation, I will get y plus del y minus y is equal to f of x plus del x minus f of x. And this y and y will get cancelled. I will get del y is equal to f of x plus del x minus f of x. So you write here it as remark. When y is equal to f of x, and when we will give the increment to this f of x as x plus del x, we will get here y plus del x is equal to this. So now del y is equal to f of x plus this thing. Divide on both sides by del of x. So here it will be del y divided by del of x, and it will be now f of x plus del x minus f of x divided by del x. So this is now the ratio of this increment is del y and del x, and this ratio is called, this expression is called incremental ratio. So it is called incremental ratio, or it is called difference coefficient. So here it is called the incremental ratio or difference coefficient. You can now we are getting the ratio of these increments del y and del x. We are getting it del y divided del x. We are getting it equals to f of x plus del x minus f of x divided by del of x. This we are getting as incremental ratio. Now you check here, we will write after this the differential in terms of incremental ratio of derivative. Now you check here, this is del y divided by del x. In triangle this PMQ, it is, we know that this PM we have drawn it as perpendicular to this line PT. Now by the definition of this tan theta, this, for example, if this is my theta here angle, this QM del y divided by del x, it is actually the tan theta. It's actually the tan theta. So del y divided by del x. Now if I will approach the del x to 0, or if I will take this q to p, that means if I will turn this q to p, or if I will, at that time this del x will approach to 0. So when I will approach the del x to 0, this pq, this chord, it will come here and it will become the tangent of this f of x at point t. So here this del y divided by del x, we know that it is actually tan theta, and this tan theta is actually the slope of this pq, slope of PQ. But when I will approach this del x to 0, this slope of PQ, this PQ will become the tangent to the curve at point P, and slope of PQ will be equal to slope of tangent. That will be equal to slope of tangent at point at P, and we know that the slope of tangent at point P, that is equal to what? That is equal to the differential coefficient or derivative of a function at the point P. So this will be now f dash of P at point P, or that is our x. So it will be f dash of x, and it is equal to, when we are approaching the del x to 0, so that means del x, limit del x tends to, so the slope of tangent at P, that is equal to, you check here, slope of tangent at P, that is equal to slope of PQ, slope of PQ, when this del x tends to 0. But we can apply slope of tangent at P, slope of tangent at P, that is the derivative, we know by the definition of coefficient, that is the derivative of this f of x at point P. So it will be f dash of x is equal to slope of PQ when del x tends to 0. So that means when limit del x tends to 0, del x tends to 0. Slope of tangent, what was that slope of PQ? That was this f of x, that was this del y divided by del x, and it is equal to this limit x tends to, limit del x tends to 0, f of x plus del x minus f of x divided by del x. This is our f dash of x now up to here. So here we can apply f dash of x, f dash of x. This thing when this limit del tends to 0, so it is now the derivative of f(x), and we know we write it as dy by dx. So when we have to find out the dy by dx, that is the limit delta tends to 0, the ratio of the increment. So that this is dy by dx, and it is equal to now f dash of x, we also denote as dy by dx. It is now the limit of the del, that is limit del tends to 0, f of x plus del x minus f of x divided by del x. So this is called the derivative of a function at point x, or this is the general definition for the derivative of function. So you write down this like here. Now we will go for this definition. It was the it was analyzation through graph. Now we will write this definition like this. Alright, now derivative of f of x at derivative of f of x. Let y is equal to f of x be a function. Be a function. Then the derivative of y with respect to this x, that increment we are making in terms of x, is defined as yes, f dash of x is equal to dy by dx, and that's equal to limit del x tends to 0, f of x plus del x minus f of x divided by del x. You write down the definition for the derivative of f of x. Now if we have to find out the derivative of f of x at some point that we have already given, that is equal to f dash of a, the derivative of the function at point a, that will be equal to limit this either this x tends to a, f of x minus a, f of x plus a minus f of x. No, this is equal to f of x minus f of a divided by x minus a. So these two you have to now take in consideration, and with the help of these two formulas we will find out the method that will help us to find out the derivative of a function at some point. Just take an example. For example, if we have y equals to and it is equal to now x square minus 4x plus 11. We have to find out the derivative of this function at point 5 at x is equal to 5. Sorry, it was called we have x square minus 4x plus 11 and we have to find out this derivative at x is equal to 5. By the first method we know that the derivative f dash of 5 it is equal to a limit x tends to 5 f of x minus f of 5 divided by x minus 5. So it will be equal to limit x tends to 5 f of x, that is x square minus 4x plus 11 minus f of 5. What is that equal to? That is equal to now it's 5 square, that is 25 minus 4 into 5, that is 20 plus 11 divided by x minus 5. So it will be now equal to limit x tends to 0, x tends to 5 x square minus 4x plus 11 is minus 5 and plus 11, that is 16 divided by x minus 5. So it will be limit x tends to 5 x square minus 4x plus 11 minus 16, that is equal to again that is equal to now 11 minus 16, that is equal to 5 divided by x minus 5. Now we know that we can make factorization here to numerator and so it will be here x square minus 5x plus x minus 5 divided by x minus 5. So it will be here limit x tends to 5 x minus 5 x minus 5 plus 1 x minus 5 divided by x minus 5. So it will come out as limit x tends to 5. X minus 5 is common, so x minus 5 x plus 1 divided by x minus 5. So this one and this one will get cancelled. We are getting this f dash of x as limit x tends to 5 x plus 1, that is equal to, we can now use the direct method, so it will be 5 plus 1, that is 6. This is by the first method. We have already discussed this method. So now the second one is that is this limit x tends to a, this f dash of limit h tends to 0 f of a plus h divided by h. We have this, so limit h tends to 0 f of a plus h, you can put here it as f of a, that is now 5 f dash of 5. So this will be now f of 5 plus h f of 5 divided by h. So you can use, so you will get here limit h tends to 0. When you will solve it, you will get h square minus 6 h square plus 6 h divided by h, and after that you can h common and that will be h plus 6 divided by h. So this one now we can use it, that is 0 plus 6, that is 6. This is the differential coefficient of f at point A by two methods. First one we have discussed it in first unit, and the second one here. Now we can find out the, we have another method by the help of which we can find out the derivative of a function at some point, and that is called Ab-initio method, or that is called another one that is known as to be the this delta method or ab-initio method. This method, the method that we have discussed, that is called delta method previously. So we will make the steps how we can find out the derivative of a function by delta method. That will be on tomorrow topic because I have some work today. So have a good time.